Good morning, class 12th. In the subject mathematics today, we will continue our integration, and today I will discuss some methods of integration. That is, previously you have made direct application of those formulas which I had given to you, but now I will explain some methods of integration, because when direct deduction is not possible, then you will apply methods of integration, which are also called techniques of integration. So here I have written, when given function is not directly reducible to integrable form, then we shall apply methods of integration. And so our first and very widely used method is method of substitution or integration by substitution method, which is also called change of variable method, because here we will do integration in terms of new variable, where you will get your function into a standard form and then you can write its integration. So I have explained here first how to apply this method. So this method is applied to integrate those functions in which any one part of the function can be written as differential or reducible to differentiation of other part. This is very important because you are beginners, and for beginners it is necessary to see this condition. As you see, you have to see before applying this method, you have to see any one part of it must be differentiation of other part, and then how to apply the method. Then the function which gives the differentiation, you will take that as new variable, say anyone t, u, v, z, etc. And then given function is completely transformed into new function in terms of new variable. And now you will see that in terms of new variable, then it can be integrated with respect to new variable easily, and after integrating it, you will change it in terms of original variable in which given originally to find the answer, in which the function was given originally to find the answer. And here, after discussing this once again, the summary is that this method is only applied when it is necessary to check first the differentiation of any one part is other part, and then the function which gives the differentiation is taken as t, new variable, change it into new variable, and then you will find it in the standard form, so that you can apply any direct formula for integration. Now these examples will make it very clear. Question number 1, evaluate sin log x upon x into dx. So here what do you observe? For integration it is not directly reducible, but log x has derivative 1 upon x. So you can take log x equal to t, so that 1 upon x dx, its differentiation is dt. So the part dx upon x will be converted into dt, and now in terms of new variable you will write the same function log sin x dx as sin t dt, and sin t is now a simple function which can be integrated easily. You have a direct formula as minus cos t plus c, that is minus cos log x plus c. Question number 2, evaluate 2x x square into dx. So answer here again, you see derivative of x square is 2x. Any one part of it must be differentiation of other. So x square is t, so on differentiating 2x dx will make it dt. So in the original function, if you will replace 2x dx by dt, then you are left with sec square t dt, whose integration is tan t. So you have seen the substitution is changing it into a standard form. You can easily write the integration. Similarly, question number 3 is evaluate integration under root 2 plus log x upon x. So what do you observe? 2 plus log x on differentiation gives 1 upon x. So 1 upon x dx is dt. Your integration is converted in terms of square root t dt, which you can write t to the power half dt, or after integration of this you will apply 2 to the power 2 upon 3 t to the power 3 upon 2 plus c, or 2 upon 3 in terms of new variable, 2 plus log x to the power 3 by 2 plus c. So make a note of it, and after noting down, show it to me.